welcome to day 6 of the 12 days of LiDAR. My name is Alex Billick, and today we're going to be talking about Arc Pro and LiDAR. Now, you notice that I titled this Arc Pro and LiDAR, and I understand that as of early December 2023, ArcMap is still in use and still widely used and does support LiDAR and has a variety of extended tools out there to try and facilitate and help work with LiDAR data and extended functionality within ArcMap. The reality is, though, that ArcMap is going away. I saw this meme from an Esri tweet, and I had to laugh, so I included it here because that's the reality. Arc Pro is 64-bit. It will take advantage of all the RAM and other system resources available. And in 2023, if you are learning LiDAR and you're going to use an Esri product, I would highly suggest that you just focus on Arc Pro. It really makes more sense to develop those skill sets because ArcMap is going to be deprecated, and then it'll be out of the support sequence. So that's what I'm going to focus on. I'm not going to touch on anything to do with ArcMap in this. I haven't used it in a number of years now. I've made the full switch. It was a little painful, but we're out the other side now. All right. There is, however, an elephant in the room when we're talking about Esri products and LiDAR, and the name of that elephant is LAS. So the big problem is that also in 2023, there is still no LAZ format support in Arc Pro. And that is a significant challenge because every data collect that I have seen for the last at least 2 years is all delivered in LAZ, whether it's in Ontario, BC, Europe, the United States. All of the publicly accessible data is all being delivered in LAZ format for all of the reasons that we talked about in the first session. It's much more space efficient. It just makes sense to go that route. But unfortunately, no Esri products support it. So if you want to open up this demo data that I've been showing you so far, you're going to have to run LAS tools and convert it, or I think there's tools in here that'll do it as well. But that is a barrier to entry. It's a point of friction between users and this tool, and it also means that you have to store a lot more, a lot larger files on your server, on your computer. Now, obviously, when I'm using Poetry Viewer, it expands out locally as well and takes up space. But when it does that, I don't have to do anything else. I just drag and drop the LAZ file and it generates what I need automatically. I can't drag and drop or I can't reference LAZ files at all in Arc Pro. I think that is something that really has to change if we're going to be able to treat Esri products and Arc Pro as a serious contender for LiDAR data processing as time goes on. If there's no support for this compressed format, that's going to be a big problem for uptake. So that's all I'm going to say on that now. Let's jump into it. What I've got loaded in so far is a reference image for the same extent we've been working on. I also added a shapefile here for the buildings on campus. Now, this shapefile comes from OpenStreetMap, so it's not perfect, but I'm going to use it for illustrative purposes here. You see that we've got a building missing here, which has been there a long time. I don't understand that one. This here is a recent addition onto the athletic facility on campus, so that makes sense to me that isn't captured the same way. So we're going to have that available to us because I'm going to show you how to deal with some data products. The way that Esri deals with LiDAR data is similar to how it deals with imagery in the form of a mosaic dataset. Here we call it a LAS dataset. So in geoprocessing, you can do this in Catalog as well. I have referenced my LAS format. I have created a LAS dataset storage container, and then I've got the coordinate systems all identified correctly here. And I'm just going to say run. And when that finishes, it's going to put it underneath the imagery. I'm just going to drag it on top. And you see that we've got a red bounding box here showing us our extent. We have to zoom in before it actually draws it, and that's fine. There we go. So I'm going to go to my symbology tab here. And right now it's being color-coded by elevation, but right now I'm going to look at it by classification. And you see that this is the raw data from the ministry now. It's not the one that I had done any classification correction to. So those buildings are being called class code 5 or vegetation. I want to fix that. The way to fix that, we'll go back to the geoprocessing toolbox and we're going to say set las class codes using features. So I'm going to give it this input data set here and I'm going to use the LU buildings features. I'm not going to buffer it. I'm not going to do anything else. I just want to show you an example of how we can use ancillary data to clean up what's going on here. One thing I also have to set is that I want to push whatever it finds to class code 6 for buildings. There we go. Say run. And it takes a moment. Depending on the speed of your computer, how many points you have in your data set. There's a lot of different factors here on how long this takes, but we'll let it run and we'll see what our results look like. So again, this isn't going to be perfect. We know there's shifts in the OpenStreetMap layer here. I'm just doing this for illustrative purposes so that I can show you how you can quickly classify some of this data. While it's thinking there, so you see it's locked the layer. Now it's going to reload it, and all the buildings are missing. Well, the solution to that is actually just going back to the symbology tab, clicking on more here, and say add all values. We didn't have any buildings in there before, so it was empty. But now you see we've got all of our buildings classified. Is it perfect? No. We'd have to do some adjustment here, but you notice that when I showed you before those tree crowns, now they're being called building. We're not respecting those at all. We just used a vector data layer to just grab everything inside of that envelope and pull it into this class. So it's another way to be able to do this kind of classification, but it has significant trade-offs as well. All right. So when we look at symbology, that's the number one thing that you can use to interact with this data. You can go elevation, intensity, scan angle, all the things that we've done before. We can also ask it to draw a surface here, so to interpolate what's going on in between. And so I can say draw using, and then I can define what I'd like it to draw using. In this case, I'm going to say draw using elevation. I'm going to turn off my classes, so I just want to see a surface based on elevation only. Now, this is again another way to be able to inspect our data and see what's going on. But this is 2 dimensions, and with LiDAR, 3 dimensions is really critical. The way to be able to interact with your LiDAR data in 3 dimensions is to go to Insert, New Map, and a new local scene. I've already loaded one with my imagery. What I'm going to do now is go in here to Map, Add Data, and I'm going to go back to my... Alright, so now it's thinking. And there is our last data. And we can actually drop down here and view this in 3 dimensions. You notice sometimes that the imagery will appear over top. This depends on if we're getting any kind of a conflict from some of these world extent data sets. If you find that that's a problem, just turn it off, and then you won't have that issue. All right. Just turn off all these other layers so that we're just looking at the LiDAR. But what we can do now is if you want to be able to take a profile, for example, and we go here to last data set layer, under view, create, and we can actually draw our profile. And the thing to pay attention to always is this little circle in the corner, and you'll see that it's actually thinking. All right. So now we've got our profile there, and we could actually go in here to settings and change the depth of that profile. So I could say 10 meters, for example, or 1 meter. And that's how wide the profile box is. The width here is referring to the length. It's all how you choose to measure this. So the terminology is not quite one-to-one from, say, Fugro Viewer or Poetry Viewer to this, but you get the idea of what where each tool resides. Once you're done with this, it was a little bit tricky to figure this out, but this little red X in the corner here lets you close that, and then you can go back to viewing your data in 3 dimensions. All right, so there are a number of classification tools that you can use. There's a lot of other extended functionality within Arc. I'm not going to try and cover all of that today. I just wanted to give you a sense of how to get data into it so that you can start to interact with it and see some of the basics of how you interact with it. As with everything GIS, there's probably 5 different ways to do everything. So if I right click on the last data set, I can actually go in and filter my data right here. So it actually has that built in. And there we go. Now we've got a interpolated surface of our DEM right there. So we've got lots of ways to interact with our data sets. We can also, I didn't show you this previously, we could go to catalog and go to the properties here. And what it actually has is for the individual LAS files, if you click on details, you can see a significant amount of information here, which is quite helpful. So we can see here what are the class codes, what percentage of our data set falls into each of those, the number of returns, everything else. So this is a very helpful tab for finding information. I find this easier to read than some versions of, say, LAS Tools Info. It's a little bit cleaner in its layout, so I do appreciate that. You also see here just how large this data set is. So one tile has 36 million points in it. So if you don't have a lot of RAM, the computer I'm using has 128 gigs of RAM. It has a modern GPU and it's running on a solid state hard drive. So it's kind of set up for success for being able to deal with this data. Your mileage may vary depending on system configuration, the amount of data you're trying to read, everything else. But with that in mind, thank you very much for listening, and tune in tomorrow where we're going to jump into QGIS and LiDAR. Thanks for listening.